Hello grade 12s. So let's check the question and the statement that we are given today. For the statement part, we are given that the gradient of the tangent to the function represented by f of x is equals to ax cubed plus bx squared at a point with an x coordinate of 1 and the corresponding y coordinate of positive 5 is 12. Meaning they are saying wherever this tangent touches my function, which function? This one. It touches the function at the point what? 1:5. And the gradient at that point where this tangent touches the function is what? Is 12. First of all, what we need to do or understand before answering this question is we need to understand the relationship between the first derivative of a function and the gradient. Remember something, first derivative of your function is always equals to the gradient at that x value. Remember, first derivative is denoted by what? Is denoted by f prime of what? Of x. This is always equals to what? Gradient m at this point x. In other words, here f prime of what? What is our x coordinate in this case? It's 1. Meaning f prime of 1 is equals to what? 12. Because we are saying the gradient at this point is equals to 12. And we are saying that the first derivative at an x value is always equals to what? Gradient m. Now let's check something. I am going to take my function ax cubed plus bx squared and derive it and equate it to what? To 12. But where I see x value, I must substitute what? I must substitute positive 1. Okay, let's go to the question. The question is, show that a is equals to 2 and b is equals to positive 3. We can see that our goal is to calculate the values of what? A and b, and show that the value of a is positive 2 and the value of b is positive 3. Now let's carry on. Remember now, I am going to take my function. This function f of x is equals to what? Is equals to ax cubed plus what? Plus bx squared. Remember, I can write this function as what? F of x is the same as saying y is equals to what? Ax cubed plus bx squared plus bx squared. Now let's check something. Remember, I'm calculating two values. I need to find two values here of what? Of a and b. Check something. In order for me to find two values, I must have two equations, meaning I need to create two equations. First of all, what I will do is that, remember here, our x is 1, our y is 5, meaning in order for them to get positive 5, they needed to substitute positive 1 where they see x. Because remember something, in order for me to get the y value, I must first have the x value, because x is the independent variable and y is the dependent variable. Meaning here I will say where I see y, I substitute what? Positive 5. This is equals to a multiplied by what? What is the x value of this corresponding positive 5? Is 1 cubed plus what? B multiplied by 1 squared. When we simplify this, we are going to have 5 is equals to a plus what? Plus b. We can either make a or b subject of the formula, but let's choose to make a subject of the formula, meaning I need to take my positive b to this other side. But remember, what jumps the equal sign changes the sign, meaning here a will be given by what? A is equals to 5 minus b. This is equation what? This is equation 1. Now let's go and create equation 2. Remember something, at the beginning of the video, we said first derivative is always equals to the gradient at the point x value. Now check something. Here, if I take my function f of x is equals to ax cubed plus bx squared and derive this function, I'm going to do a first derivative of this function and equate it to what? To 12. But when I see x, I must substitute what? Positive 1. Because we are saying first derivative is always equals to what? Gradient. In other words, here, I will have f prime of what? Of x is equals to, remember the rule of deriving, we always work with the rule of what? Exponent multiplied by coefficient, exponent minus 1. In other words, here, what is coefficient in this case is a. What is exponent is 3. Meaning I'm going to say 3 multiplied by a, which is what? Which is 3 Ax, but I go back to the exponent and say exponent minus 1. This means this will be 3 minus 1, which is 2 plus 1. What is the coefficient here? Is b. What is the exponent? Is 2. Meaning I'm going to say 2 multiplied by b, which is 2b, x to the power of what? X to the power of what? But remember something. They said to us the gradient at this point is 12. Meaning here I will say what? I will say 3a, where I see x, I must substitute positive 1. This is going to be multiplied by 1 squared plus 2b multiplied by 1. This must be equals to what? What is the gradient at that point? Is what? Is 12. Meaning I have 3a plus what? Plus 2b, which is equals to what? Which is equals to 12. Remember something. We said where we see what? A, we substitute 5 minus b. In other words, here I will have what? 3, this is a. Where I see a, I substitute 5 minus b. In other words, I have 5 minus b plus what? 2b is equals to what? Is equals to 12. Hey, now, let's check something. I need to first break my brackets. When I break my brackets, I have what? I have 3 multiplied by 5, which is positive 15. 3 multiplied by negative 3b, which is negative 3b, plus what? 2b is equals to what? Is equals to 12. Yeah. So here we have 15 minus 3b plus 2b is equals to 12. Now I must simplify my left hand side. When I simplify my left hand side, I have what? I have 15 minus what? Minus 3b plus 2b is always equals to b, which is equals to 12. Here I must calculate the value. What is the unknown in this equation? Is b, meaning the goal is to calculate the value of what? Of b. This will be 15 minus what? Minus 12 is equals to positive b. In other words, my b is equal to 15 minus 12, which is equals to 3. We have shown that the value of b is equals to what? 3. But remember, when we see a, we see what? When we see a, we see 5 minus b. Remember something. If I see a is equals to 5 minus b, where I see b, I will substitute what? Positive 3. In other words, I have a, which is equals to 5 minus 3. A is equals to what? A is equals to 2. We have shown that the value of what? Of a is equals to 2. Let's